It's space weather! Looking at sunspot 2729 as it releases the largest solar flare seen in months. Also, we've got some active regions on the northeastern area. Not sunspots, they are plages. A plage is a sandy beach, or an active region usually associated with sunspots. In this case, not. Let's let that run through one time in 304 angstroms. And then we'll zoom in on that sunspot as it produces the flare, and my coffee becomes done. And there's that sunspot up to the last few minutes. Let's look at the magnetic lines. Looking pretty much as expected. And let's take a close-up, an ultra high-res sunspot close-up here. There you go. Right about when that flare came out. Gonna take a look at it. So let's head to spaceweathernews.com. Take a look at the X-ray flux. That flare has just dropped off. Check it out. That's the biggest and longest duration flare we've had in probably 6 weeks, maybe 2 months. I'm not going to go back and check, but if you do, feel free to put in the comments. Let's look at the real-time solar wind. BTBZ is looking pretty flat. Phi angle's not producing any real signal. Solar wind density is right under 10, like about 8.9 or so. Solar wind speed has dropped back down. It peaked overnight at about, looks like about 600 kilometers per second. So it looks like that solar wind is coming down a little bit. Let's look at the rest of the data. Magnetometer just converging, and midnight local time for those satellites indicates that we're going to have an uptick. KP is back to 1. Low-level cosmic ray alert. And the electron flux has reached its highest level in quite a while also. Probably associated with all that activity on the sunspot and the other active regions. Although, not a whole lot of charging hazard. And the F2 layer is actually looking quite weak again. So that should be charging up, especially as the magnetometer spikes. Same anomaly we saw yesterday. Although it doesn't look as deep as it was yesterday. Let's watch for that to charge up. Your auroral forecasts are awfully weak. Let's look at the Space Weather Enthusiast dashboard. And looking at the X-ray imager, be able to see where the X-ray flare came from. And that is right there. Right at the end of the video, you'll see it explode a little bit. And that was your X-ray flare. Let it play through one more time for those of you who didn't see it. And that is what an X-ray flare looks like. Let's look at solar ham. Look at the magnetometer data. The magnetogram, that is. If you ever want to do this yourself, Just go to solarham.net. We'll leave links to all the sites we use in the description. And there's your sunspot 2729 as it sets. Pretty complex. You can use the stereo satellites to continue to follow that. Since we put up a cosmic ray alert, a low level one, we figured we'd look at some cosmic ray monitors. Nothing too special at Oulu, Finland. This is the Athens cosmic ray detector, a neutron monitor, and nothing too special there. You can see that this kind of agrees here that the highest levels that we had were around December 2nd. Check out Mexico, pretty much the same deal, agreeing with the highest cosmic ray levels around December 2nd. We did have a spike yesterday in both of these detectors. Check out Moscow. And also agreeing with the highest level, December 2nd. And before we get into some Earth weather stuff, I'd like to go through our officially endorsed channels yet. Sky Scholar, Oppenheimer Ranch Project, Suspicious Observers, and we've got 3 new ones. Adapt 2030, Suspicious Observers, Adapt 2030, The Climate Guy, who's a meteorologist, and Ice Age Farmer, who is I'd say a grand solar minimum prepper. So check out all those channels if you haven't already. Let's look at a little bit of Earth weather here. All right, we've talked about meridional jet stream flow quite a bit. Let's give you an idea of what it looks like. And that is what it looks like. You can see this compression right here. That's what's causing Winter Storm Diego to stagnate for as long as it is. Fortunately, this is going to slowly slide out to the east, and it's going to allow all this to move up to the northeast a bit. But it's still going to stagnate for quite a while. Let's just give you an idea of how it got there. Here's your jet stream pattern. Let's advance this slowly. The jet stream's splitting apart, getting sucked up to Alaska. And then an extremely high pressure system forming. And that brings us to current time. Let's look at the Southeast AccuWeather Doppler radar. Again, we'll leave links. You see how that storm is stagnating? Well, everybody in places like North Carolina and Tennessee are wondering when it's going to move off. I invite you to check out the NASA GOES water vapor map. So, remember, important thing to understand about weather, water vapor maps, etc., is that dry air is more massive than wet air. And so you want to look at what the dry air is doing in order to, figure out what's going to happen. Now, in this situation, there's a couple different things occurring here. The jet stream is still coming down like this, and it's still holding that moisture off right about Pennsylvania. But fortunately, this massive air is going to push in, and it's going to allow this system to slowly move out to the east and to the northeast, and give the southeast a break. Thanks everybody for watching. Please don't forget to like and subscribe to videos. More coming out daily. We'll be staring at the sun. We'll be looking at crazy physics, astrophysics topics. Remember, on your way to staring at X-ray flares, don't drink. And if you drink... Oh, I saw some ejecta. Check it out, right there. Time to extend the episode. Heading back to Solar Ham to look at the LASCO C2. Looked like the southeast corner there. You'll also see the X-ray flare at the end of this, probably. Yeah, a little bit of a coronal mass ejection there, coming out of the eastern side. Let that play through again. Right up here. Right up in this area. Small coronal mass ejection. No X-ray flare apparent at the end of that one. Anyway, just thought we'd quick cover that since we know. Now remember, when you're staring at the largest solar flare in the past 2 months, don't drink. And if you drink, stare at the solar flare anyway. It's epic. Actually, it's pretty small, but thanks for watching anyway.